This is a video that starts out pretty straightforward, pretty easy, even boring maybe, and it ends up with one of the most difficult and powerful aspects of the C programming language. So get ready. We're going to start out by modularizing the sort program. We're going to make a function for swapping, right? That's where we're going to start. It seems a little dumb at first because it's only a few lines of code. It doesn't seem like it makes it that much simpler, but stick with me. I have my reasons. I'm a professor after all. I get to make up all these examples and just to prove a point. So I'm proving a point, and boy is it a big point here. Okay. In this program, we're going to start with sort as our template. So you go into Finder, and you find the sort folder, and you make a copy of it. You change the name to swap. You go in, and you delete the executable, and you change sort.c to swap.c, and then you double-click on that, and it comes up in Xcode. Okay. Now let's make a swap function with two characters at the input, char alpha underscore A and char alpha underscore B. Those are the inputs. What's the output of this function? There is none. I just want to swap the contents of the two input variables. So in that case, when you have a function that you don't want to return a specific value of, and you just want to do stuff to the input arguments, you call that void. So you put void space swap, and then parentheses, char alpha sub A and comma char alpha sub B. That's the declaration statement at the top. Then you copy that and paste it below main, and take away the semicolon, put in curly braces, and then at the bottom of that function, you're going to say return semicolon, nothing with the return. It's just return only. For void functions, you got to just return with nothing after it. Okay, that's it. So let's just cut out the swapping part inside the if statement there of the main program and put that down into the function here, swap. And then we don't need to declare temp in main, and then we just call swap, and we say alpha bracket j I and alpha bracket j, right? Just swap them in main, and it all should work no problem. Everything's fine, right? Okay, so I'm going to go into the terminal. I cd desktop, cdc code, then I cd into swap. Then I compile swap.c, and I run it. And there's the answer right there. Except it didn't work. Look, it's the same. It's QWERTY before sorting and it's QWERTY after sorting. It didn't alphabetize it. It didn't work. Huh? What happened? Now what? I don't know what to do. It didn't give me. Geez, the compiler did give me an error or something like that, but I got an error just the same. There's an error in the algorithm somehow. There's an error in this function that I did, and I don't know what it is. I need to troubleshoot it. So I don't normally troubleshoot this way, but I'm going to do it this way. I'm going to stay in the same folder, and I'm just going to take swap.c and copy it and paste it, and then change the name to swaptest.c. So this is just a test swapping program inside the same directory, inside the same folder. I double click on that, and it comes up in Xcode. Then I'm going to do a couple things. I'm going to make a much smaller data set, just ABCD, right? Just 4 letters. So I take all the QWERTY out and I just put ABCD, and I'm only going to switch 2 letters, D and C. So ABDC is the input array string of characters that we're going to input into this alpha character array. Right? So it's a much smaller thing, and swap, the function swap, only gets called once. Then I'm going to add a lot of printf statements. I add a printf statement inside the if statement, but outside of the swap function. So that's what I mean by outside in main. Outside means in main. So inside before, I'm going to print those characters out. Inside out, outside after, I'm going to print the characters in main there. And then inside swap function itself, at the top of swap, I'm going to print out what the dummy variables have in them and see at the bottom, did they get switched? So is it switching inside the program? Is it switching outside the program? This is what I want to know, right? Where's the error? Is the error inside the function or is it inside main? Okay, so I save that, I compile swap test.c, and when I run that, you can see that outside before it's not switched, inside before it's not switched, inside after it is switched, but outside after it's not switched. So the data gets switched inside the swap function, but then it doesn't translate back out to main. This is the main point I want to make about this video. When you call a function, a copy of the variables is sent to that function. A copy of alpha sub I and alpha sub j is sent, not the variable itself. And so the program just swapped copies, swapped the contents of two copies of alpha sub I and alpha sub j, not the actual array itself. When we do it for something like average, when we take the average of a copy of an array, that's like in Excel. If you have a column of numbers and you cut and paste it to a different column, and you take an average of that column instead, you're going to get the same number, whether you take an average of the copy of that column or the column itself, right? If it's just values. So we haven't had this problem before, but now that we want to do an actual swap thing, this problem has reared its ugly head. In lectures, I always use the analogy of moving from one house to another. For example, if I'm moving from 221 Baker Street to 10 Downing Street, for example, if I'm Sherlock Holmes and I'm become Prime Minister, I don't know how that would ever happen, I would have to move, right? And so I would take the boxes that are in 221 Baker Street and move them to 10 Downing Street. All those boxes, if I'm Sherlock Holmes, are just filled with pipes and deerstalker hats. That's it. That's all he has in those boxes, I'm sure. So the analogy of moving to what I just did in this swap program is doing that all in main. So moving the boxes from one place to another yourself is the equivalent of doing everything in main. Doing everything in a function, this function swap, is the equivalent of hiring a moving company, telling a moving company, hey, swap those for me. Move these boxes from this house to that house. What happened in the swap function, in this analogy? In the analogy, what happened is you put the houses themselves in the input arguments. And so in this magical C compiler world, you made copies of those houses. You created a whole new universe, a whole new London, if you will, with a copy of 221 Baker Street and a copy of 10 Downing Street. They're not the real things. There's often some new universe with new memory with new addresses and everything, right? On different streets. And so the moving company goes to that copy of 221B Baker Street and moves all the boxes to the copy of 10 Downing Street, so that when you go to the real 10 Downing Street and the boxes haven't been moved there, you go, hey, what's up, to the mover, and who goes, I moved it, I did my job, right? And but it didn't happen in the real world because they moved it in the copies, not the real ones. In this analogy, in the swap function, as soon as you hit the return statement in the swap function, this whole universe, this whole new London where you have the copies of these houses disappears. They vanish into thin air. Even the moving company people vanish into thin air. And so in the analogy, you couldn't even ask them if they did their job or not. They don't exist. The whole thing's gone. The way to solve this problem in this with these weird movers, instead of putting the house in the input arguments and make copies of the house, you take 2 sheets of paper and you write out the addresses of the real houses on those sheets of paper. Then you give them to this function, this moving function, you give them to them, and they make copies of those pieces of paper with the addresses of them. But a copy of 221B Baker Street is still the right address. It's still 221B Baker Street, and a copy of Town Downing Street is still the same address. It's still the right address. And so if you give the mover copies of the addresses of the actual real houses, then they can move they go to the actual 221B Baker Street, pick up all those boxes and move them to the actual 10 Downing Street. It works. That's this analogy. The analogy here is what we have to do in this swap program is we have to pass these pieces of paper with the addresses. We have to pass the addresses of the variable into the function, not the variable itself. This is where star and come in. We've used those variables a little bit. If I declare a variable and the variable has a star in front of it, that means that variable is now called a pointer. We've already used pointers before. Star FP and star argv are good examples. Pointers are different from regular variables, as I'm going to show in the following table. If I want to know the address of the location of that pointer, I just take away the star. The variable name itself is the address of where in memory, where in computer memory that variable, the contents of that variable, is stored. Star, and then the name of the variable, like star alpha, is how you say what the contents of that memory location is. So if you want to assign a value to that pointer variable, you say star alpha equals something. If you want to know the address of it, you just say alpha. Regular variables like this variable beta, a character variable called beta, regular things, if you want to assign a value to beta, you just say beta equals something, right? And if you want to know the address of beta, you use the ampersand and the and sign. So ampersand beta is the address of where that memory, where that data is stored in your computer. So that's the key. So for pointers and regular variables, it's different, right? So that's the convention in general, right? Star and nothing for pointers, nothing and ampersand for regular variables. If we're doing address-related stuff in general, usually it's a good idea to use pointers. We're going to use pointers in a lot of their contexts too later on, so you can learn more and more about pointers. In general, that's the case, not always, but a lot of the times. For now, it's just a rule to follow. It's just something I gotta know is, if I'm using address-related stuff, it's a better idea to use a pointer variable. Okay, that's gonna come up later in this point I'm gonna try to make here. So, back to the swap function. If we want it to work, we have to send the address of alpha sub I and the address of alpha sub j into the function, right? So I put an ampersand in front of alpha I and an ampersand in front of alpha bracket j. When I do that and I compile it, I get all sorts of errors, right? So don't do that, right? It's going to say file mismatch type and all that stuff, or data mismatch type, variable mismatch type. So what you have to do is inside swap, you have to tell it, I'm going to send you an address. The way to do that is to convert alpha underscore A and alpha underscore B, and convert those to pointers. And then, so you've got to put stars in front of them everywhere, including down, say, the contents of alpha sub A, put the contents of alpha sub A in temp and so forth. So put stars all in there inside the swap function as well, and then go up to the top and make sure there's a star in the declaration statement on the top. So then when you compile swap with all the stars there and the ampersands in front of alpha, alpha bracket I and alpha bracket J inside the swap call, then all the errors go away. Then I go back into my command prompt and I compile and I run swap now. Now it works. Now because I've sent the addresses of where those where alpha has stored the ith and the jth components, right? D and C in this case, right? Where in memory, in computer memory, did they store the D? Where in computer memory did they store the C? When it's in the addresses, then the moving company swap actually does the process right when it has the addresses. Cool. We've already seen this convention before. Just look up at the fscanf statement. We had to put an ampersand in front of a sub I for fscanf. For all scanf and fscanf statements, we've had to put that ampersand in there. Why? Because fscanf wants to take a copy of the number that it's reading from a file and put it into the real a sub I location, not a copy of the a sub I location, so you have to send it the address of. Printf, we can take a copy of the average value and print it out, and it's going to be the same thing as the copy of the average value is going to be the same as the original average value, and so you don't need to use ampersand there when you're just printing something out. But when you want to scan something in and put it into an array, you have to have the ampersand there. So this explains why the ampersand is in scanf and fscanf statements. We've learned so much in this video. We learned what a pointer is. We learned what star and do for the different types of variables. The star symbol has a fancy name. It's called the indirection operator. It has other names too, but some people call it the indirection operator. And the process of assigning value to the contents of a pointer is sometimes called indirection or dereferencing. So you might hear the term indirection or dereferencing when you see pointers and when you see stars and ands and things like that. We've learned that functions take the copies of variables as input. And so if you want to change those variables inside the function, you have to send it by address, not by value. We've even learned a couple of troubleshooting strategies, right? We made a test program with a smaller data set, a much smaller data set with a really controlled data set where only one thing's changing, right? And then we used a lot of printf statements inside and outside of functions to sort of diagnose where the problem actually lied. Wow, turns out this video was pretty important after all, and we learned a lot of stuff with a very, very simple beginning.